Hello friends and my dear students, I welcome you all to my channel. If you are new to this channel or not yet subscribed, I will highly suggest and request all of you to support me so that your support will help me grow my channel and also motivate me to come up with videos on middle school mathematics, physics, and very soon I will start computer applications and computer science. Uh, And also please do not forget to press the bell icon so that you will be notified by my future videos. Thank you. So this video is part of the playlist CBSE Mathematics Class 7 following the textbook of author RS Aggarwal. This is class number 2 on the chapter Exponents. If you have not watched the class number 1 on Exponents, I highly suggest that you please watch that first to get introductory information about the exponents. In this video I will start to discuss the laws of exponents, which are very important and crucial for your future classes, especially 11 and 12. It is very important that you understand this concept very clearly. So this is part 1 of laws of exponents, because there is a lot to cover, and in this part 1 I will discuss about the multiplication, division of powers and the reciprocal of powers, and will solve few problems from the exercise 5a. So let's get started. Okay, so I have my notes on the left hand side, and on the right hand side I will discuss any concept required and will solve the problems. But before starting the laws on exponents, I will just recall what I discussed in class number 1. So we discussed about the exponential form of a number, which is of the form a to the power n, or it is said a raised to the power n, where a is a number, where is a non-zero number. The number could be an integer or a rational number. N is a positive integer. So please remember that n is a positive integer and a is a non-zero number. Now a raised to the power n is nothing but a multiplied by itself n times. So as you can see on the notes, a multiplied by a multiplied by a multiplied by a, this way n times is known as the expanded form, and we in short as a notation write it as a raised to the power n, which is on the right hand side of the equality. So a raised to the power n is known as the exponential form, and the a multiplied by a multiplied by a, that is known as the said to be in expanded form. Now further we discussed about a rational number, the exponential form of a rational number, that is a rational number a by b raised to the power some m, where m is a positive integer, and we discussed that rational number a by b raised to the power m is equal to a to the power m divided by b to the power m. Now in the exponential form, a to the power n, a is known as the base and n is known as the exponent or index. Also we studied that the reciprocal of a rational number is denoted as a by b raised to the power minus 1, and that is nothing but the reciprocal of the rational number a by b, which is nothing but b by a. We also discussed about the reciprocal of a rational number in exponential form, that is, if we have so this one a by b the exponential form of a rational number is a by b raised to the power m. That is the exponential form of a rational number, and its reciprocal is b by a raised to the power m. So for example, we have a rational number 2 by 3. This is an exponential form of the rational number 2 by 3, where the base is 2 by 3 and the exponent is 3. Now its reciprocal, we write it as power minus 1. Now this is nothing but we just this is nothing but the reciprocal of the rational number, that is 3 by 2 raised to the power m, where m in the example is 3. So this is this. Okay. Also I discussed that any negative number raised to the power n, where n is even, it is equal to the numerical value of the number raised to the power n. So this any negative number where a is a positive number, so minus a will definitely be a negative number. A could also be a could be an integer or could be a rational number. If we have an exponential form like this, now this will be equal to a numerical value of minus a is a, so a to the power n m if n is even, like 2 4 0 2 4 6 8 like that, and this will be minus a to the power n, negative of a to the power n if n is odd. So this is important thing to note. So that was it that I discussed in the class 1. Now let's start in this video the laws of exponents. The laws of exponents you have already studied in your previous classes, like class 6, related to integers. So the same laws holds for rational numbers. Specifically, we will understand how the laws of exponents works for rational numbers. So the first law says that a rational number, if a by b is a rational number, that is a and b are positive integers, and m and n are in all these laws, in the notations we have used a, b, m and n. So a and b are positive integers, and m and n are a and b are non-zero integers, and m and n are positive integers. So a rational number, let's say a by b raised to the power m multiplied by the same rational number raised to the power n is equal to that rational number raised to the power m plus n. So we have let's say 2 by 3 raised to the power 2, that is square of 2 by 3 multiplied by the same base. 2 by 3 multiplied by 3 is nothing but the same base multiplied by, we sum the raised to the power, we sum the exponent, that is 2 plus 3, this is 2 by 3 raised to the power 5. So this is law 1. Okay. Law 2 says that this was the law 1 is the law of multiplication of two exponents. By exponents I mean when I will say exponents and powers, I mean a rational number raised to an exponential form of a rational number, that is a by b raised to the power m or n. So that is what I mean when I say an exponent, powers or exponents. So the law 1 is a product of two exponents having the same base and but different power. Power means the exponent or index. The law 2 is a division of two exponents where the base is same but, and the powers of the exponent are different. So we have the a by b raised to the power m divided by the same rational number a by b raised to the power n will be equal to a by b raised to the power m minus n if m is greater than n. If m is greater than n, it will be a by b raised to the power m minus n, and if m is less than n, then it will be 1 by the rational number a by b raised to the power n minus m. Okay. So for example, if we have, let's say, 4 by 5 raised to the power 3 divided by the same base 4 by 5 raised to the power 2, this is division of two exponents of powers, will be equals to, in this case, m is 3 and n is 2. So m is greater than n. So this will be the base which is common raised to the power m minus n, that is 3 minus 2. This is 4 by 5. This is 4 by 5 raised to the power 1, but anything raised to the power 1 is that number only. Okay, this is this, and if we have, say, 3 by 2 raised to the power 5 divided by 3 by 2 raised to the power 7, then in this case we have m which is 5, n is 7, so 5 is less than 7, so we will have 1 by 3 by 2, the common base raised to the power n minus m, that is 7 minus 5. This is equals 1 by 3 by 2 raised to the power 2. Now raised to the power 2. Okay. So this was law 2. Now law 3. Before law 3, let me discuss law 9. Law 9 is important. That is, a rational number, an exponent, when a rational number in exponent form is raised to is again raised to a power. That is, we have a rational number, let's say a by b. So a by b is a rational number. We raised it to the power m. So this is a rational number in exponential form. Now, if we raised this number, whatever this number is, again to a power n, then the result is nothing but the same rational number, that is the base a by b, raised to the power, we just multiply the two powers, m into n, that is mn. This is the result. Now, if you can clearly understand why this formula is coming, from where this formula is coming. So basically, what is happening? Okay, I will discuss this later on. You should remember this formula, that a rational number, when it is raised to a power m, and that whole is again raised to the power n, then the result is the rational number, that is the base, raised to the power, the product of the two powers, m into n. Okay. Then we have, now this is the case for two powers. This extends, this applies, holds for any number of powers, meaning, so let's take an example. So 2 by 3 raised to the power, let's say square, and again I raised to the power 3. So this is nothing but 2 by 3 raised to the power, are just the power will now be the product of the two powers, that is 2 into 3. So this becomes 2 by 3 raised to the power 6. Now this can be extended to any number of powers, Let's say I have 4 by 5 raised to the power 3, again raised to the power 2, and again raised to the power 5. So this is nothing but the base, that is the 4 by 5 rational number raised to the power, the power will now be the product of all the powers, that is 3 into 2 into 5. So this is 4 by 5 raised, what is happening, raised to the power 630. I hope it's clear. Again, just to give you an example, what will be 1 by 3 raised to the power 3 raised to the power 2 and raised to the power minus 1. This is nothing but 1 by 3 raised to the power minus 6. The last power minus 1 is nothing but a reciprocal. So, okay. Now there are some other laws. Okay, one more. The other important thing is that any number raised to the power 0, any non-zero number raised to the power 0 is always 1. So any number 2 raised to the power 0 is 1, minus 4 raised to the power 0 is 1, 1 by 3 raised to the power 0 is 1. Any non-zero number raised to the power 0 is always 1. I'm giving you some examples so that you have a idea. Whatever, if the last power, if you have a compounding power like minus 2 by 3 raised to the power 3 and then again whole raised to the power 0, whatever, if the last power is 0, it overall becomes 1. Okay, and another thing is that the law number 3, if you have the power is a negative integer, that is a rational number a by b raised to the power minus m, where m is a positive integer. So we have now in the power a negative integer. It is nothing but you just take the reciprocal of the rational number and then raise it to the power m. So for example, 2 by 3 raised to the power minus 6 is nothing but, since the power is a negative integer, you just take the reciprocal of the rational number, that is the base, which is 3 by 2, and raise it to the power 6, not minus 6, 6. Okay. So this is all about the laws. I did not discuss all the laws, but these are the laws that based on which I will do the problems. If you wish, you can take a screenshot. It's very clumsy. Anyway, if it helps, you can take a screenshot of this discussion part. Okay, now let's solve some problems. Okay, so this is exercise 5A, and from exercise 5A from the textbook of author RS Aggarwal. Question number 6. These are some powers of 0. And so let's do it one by one. So this is minus 3 raised to the power 0. As we discussed that any number raised to the power 0, whatever the number be, it doesn't matter, is always 1. Okay. This one is 6 raised to the power 0 plus 7 raised to the power 0 is 6 raised to the power 0 is 1, 7 raised to the power 0 is 1. So this is 2. Okay. Question number 7. While I am solving it and discussing, you can pause the video and take a screenshot of the solution. Okay. Question number 7. Simplify to rational numbers. So we are given some expressions of exponents. By exponents I mean powers of rational numbers. We have to simplify them, all of them, to a single rational number in the form p by q. Okay, so let's do number 1. This is 3 by 2 raised to the power 4 multiplied by 1 by 5 raised to the power square. Now we can see that the base are different. This is a multiplication of two exponents. By exponents I mean a rational number raised to the power some power. Now the bases are different. Also the exponent, that is powers or indexes, are also different. So we cannot apply any law. We have to directly evaluate it. By that I mean we know that a by b, a rational number raised to the power m, is equals to the numerator raised to the power m, a to the power m, and b to the power m. We have to simply apply this. So this becomes 3 raised to the power 4 divided by 2 raised to the power 4 multiplied by 1 square is 1, and this is 5 square. This is 3 raised to the power 4, I guess, is 81, and 2 raised to the power 4 is how much? 16, and this is 25. Now I am not doing it all the calculation part. So this is basically this thing. I am leaving it here. I hope you can do the calculation and any cancellation if required. So I am just discussing and solving the main steps. So here we expanded. Here we use the formula a by b to the power m equals to a to the power m by b to the power m, and we expanded. We expressed 3 by 2 raised to the power 4 as 3 to the power 4 divided by 2 to the power 4. Similarly, 1 by 5 raised to the power 2 is 1 divided by 5 square. So we have this rational number. Okay. Let's do number 2. This is minus 2 by 3 raised to the power 5 multiplied by minus 3 by 7 raised to the power 3. Here also we see that the base are different, and also we cannot really apply any law. Also the the powers, the exponent or the indexes are also different. 5 or 3 are different. So we have to expand each individual power by using the formula a by b raised to the power m equals to a to the power m by b to the power m. So this is equals to minus 2 raised to the power 5 divided by 3 raised to the power 5 multiplied by minus 3 raised to the power 3 divided by 7 raised to the power 3. Now minus 2 raised to the power 5, you see we have discussed that any negative number when raised to the power some odd power, 5 is odd, it is minus negative of 2 raised to the power 5. So minus 2 when raised to the power 5 is equals to negative of 2 raised to the power 5, and we have 3 raised to the power 5. Similarly over here we have minus 3 raised to the power minus 3 cube. So cube power is 3 is odd, so this becomes minus of 3 3 and 7 3. Now this is nothing but minus minus gets cancelled. In the numerator minus minus gets cancelled, so this is what 2 to the power 5 into 3 cube divided by 3 5 multiplied by 7 cube, and you can do the calculation and do any kind of cancellation required. So I am not doing that, I am leaving it here. I hope you can do that. So this is should be the answer. Okay, 1 2 and so 3. Let's do 3. Three is what? Let me copy paste it. Let me copy paste this. Okay, duplicate. Okay, let's do this one. Okay, so we have this expression, we have products of 3 exponents, that is we have 3 rationals raised to some power. So over here also we see that the bases are different and the powers are also different, so we have to expand just like we did in the previous 2 problems. So this is minus 1 to the power 5 divided by 2 to the power 5 multiplied by 2 cube multiplied by 3 square divided by 4 square. Now minus 1 raised to the power 5 will be minus negative, since the power 5 is odd, 1 to the power 5, this is into 2 to the power 3 multiplied by 3 square divided by 2 to the power 5 multiplied by 4 square. Okay, now you can do cancellation. You can see that over here this will be minus, the whole numerator will be negative, and 1 to the power 5 is 1. So we have 2 cube multiplied by 3 square, and we have 2 to the power 5, 2 to the power 5 and into 4 square. 4 square can be written as 2 square. 4 is 2 square, and again this is power 2. So this is minus 2 cube multiplied by 3 square divided by 2 to the power 5 into, so this is 2 square and again raised to the power 2. So this will be 2 to the power 4. Why 2 to the power 4? We have used the formula concept when a by b to the power m is again raised to the power n. This is a by b raised to the power m n. So in this case 2 to the power 2 and again to the power 2, m and n are 2 and 2. So 2 square raised to the power 2 is 2 to the power 2 into 2, that is 2 to the power 4. Now you can see that So this is this is minus 2 cube into 3 square, and the denominator, it is to base is same, the powers are different. 2 to the power 5 multiplied by 2 to the power 4 is nothing but 2 to the power 5 plus 4. This is minus 2 cube 3 square divided by 2 to the power 9. Now let's so 3 square is 9, so let's put aside minus 9, and we have 2 cube divided by 2 9. This is minus 9 2 cube divided by 2 to the power 9, and we have 2 cube divided by 2 to the power 9 is we can use the formula, the second one from the notes. Please check the notes on the left hand side. The second law, in this case 2 cube divided by 2 to the power 9, 3 is less than 9, so this will be, as per the formula, this will be 1 by 2 to the power 9 minus 3. This becomes minus 9 multiplied by 1 by 2 to the power 6. So this is minus 9 by 2 to the power 6 is how much? 64, I guess. So this is the answer result. 2 to the power 4 is 16, 32, yes, 9 minus 9 by 64. You can take a screenshot. Okay, so 3 is done. Okay, so we have another one, that is this one. We have another one, this. We have to do this one. Let me see if I have space left. We have to do this one. Okay, let's do this one. So this is we have a subtraction of two exponents, the first part, multiplied by 4 square. So we have to evaluate both the exponents, that is cube inside the third bracket, inside the second bracket, that is curly brace, evaluate the powers and then do the subtraction, and then finally multiply, do the multiplication with 4 square. So we have to do it step by step. Remember one thing, that this chapter exponents, these powers might look daunting in the first place, but might look very complex when there will be a lot of powers and reciprocals and division of exponents by another. It will look little complex, but you should not worry, and just focus on your basic fundamental laws and concepts and apply them, and slowly try to solve the problem. Do it step by step. So over here, first we have to evaluate minus 3 by 4 raised to the power 3 cube, that is minus 3 cube by 4 cube, minus this is minus 5 cube, and this is 2 to the power 3. This is multiplied by 4 square. Okay, so this becomes minus 3 to the power 3 is minus of 3 to the power 3, that is 27. 4 raised to the power 3 is 64, minus minus 5 raised to the power 3 will be, since power 3 is odd and the base minus 5 is negative, it will be minus of negative of 5 to the power 3, that is minus 125 divided by 8 multiplied by 4 square. Okay, so now this is, we have to find the subtraction of two rational numbers, and we know that when the subtracting a rational number is equivalent to addition of the additive inverse of the rational number. So this is minus 27 by 64 plus additive inverse of minus 125 by 8, that is 125 by 8, and this is multiplied by 4 square. Now this is the addition of two rational numbers. The denominators are different, so we have to first convert them to their equivalent rational number so that they have a common denominator as the LCM of the two denominators. So in this case, the LCM of 64 and 8 is 64. So this will be minus 27 divided by 64 plus this will be 125 into 4, that is how much, 600 divided by 125 multiplied by 8, 125. To make the denominator 8 64, we have to multiply both the numerator and the denominator with 8. So this will be 125 into 8, which is 1000 divided by 64 multiplied by 4 square. This is 1000 minus 27 divided by 64, and 4 square is 16. This is 973 by 64 multiplied by 16. 16 gets cancelled, 4. So this is 973 by 4. Okay. So this is 973 by 4. Okay. You can take a screenshot, and please do let me know. Please do check if I am doing any calculation mistakes or not, because I am prone to mistakes, prone to make mistakes. If you see any mistakes, please do let me know in the comment section. I will appreciate that. So this is done. Okay, so question number 7 is done. Let's see next question. Question number 8 is again simplification to rational number, and okay, so let's do it. Number 1. Oh, number 1. Okay, so number 1 is already here. So this is number 1. Now this is minus 4. Okay, so we see it's 4 by 9 raised to the power 6 multiplied by 4 by 9 raised to the power minus 4. So we see that we have a product of two exponents where the base is same. So we will apply the formula a by b raised to the power m multiplied by a by b raised to the power n is nothing but a by b raised to the power m plus n. So this becomes 4 by 9 raised to the power 6 minus 4, that is 4 by 9 raised to the power 2, that is 16 by 81. This is the answer, 16 by 81. Okay, let's do number part 2. Minus 7 by 8 raised to the power minus 3 multiplied by minus 7 by 8 raised to the power 2. So we see it's a product of two exponents. By exponents I mean a rational number raised to some power, and the bases of the two exponents are same, that is minus 7 by 8. So we can directly apply the formula, and this becomes minus 7 by 8, and we just add the powers, minus 3 plus 2. So this becomes minus 7 by 8 raised to the power minus 1. A power of minus 1 means it's the reciprocal. So this is nothing but the reciprocal of the rational number minus 7 by 8, which is 8 by minus 7. But we do not keep denominators negative. We have to make the denominator positive. So this becomes minus 8 by 7. We make the denominator positive by multiplying both the numerator and the denominator with minus 1. So this is minus 8 by 7. Okay, question number 8 is done. Question number 9, express as a rational number. Okay, so we have to express all of this as a rational number. So let's see. So number part 2 is minus 2 raised to the power minus 5. Minus 2 raised to the power minus 5. Okay. So we have seen that any number raised to the power a rational number, see the law number 3, rational number raised to the power negative power, that is a by b raised to the power minus m, is nothing but the reciprocal of the rational number a by b raised to the power m, that is b by a raised to the power m. Now this is nothing but minus 2 by 1 in the rational form raised to the power minus 5. Now we have a rational number raised to the power of a negative integer. So this will be nothing but the reciprocal of minus 2 by 1, that is 1 by minus 2 raised to the power 5. Now this is now you can break it down, you can convert it as a rational number as 1 to the power 5 and minus 2 to the power 5 using the formula a by b raised to the power m equals a to the power m divided by b to the power m. So now this is 1 to the power 5 is 1 and minus 2 to the power 5 is, since the base is negative and the power is odd integer, this will be minus of 2 to the power 5 minus of 2 to the power 5. This is 1 by minus 32. So this is 1 by minus 32 and we would like to make the denominator positive, and this becomes minus 1 by 32. So this is the rational number. Okay. So part 4 says minus 3 by 4 raised to the power minus 3. Okay. Minus 3 by 4 raised to the power minus 3. We know that a rational number a by b, when raised to the power some negative integer, we know that it will be the reciprocal of the rational number, that is 4 by minus 3 raised to the power the numerical value of the power, that is 3. The numerical value, the power is minus 3 and its numerical value is 3. By numerical value means the absolute value. So this is as per the formula a by b raised to the power minus m equals b by a raised to the power m. Now this is 4 raised to the power 3 divided by minus 3 raised to the power 3. This is 64 divided by, now minus 3 raised to the power 3, the base is negative, that is minus 3 is negative and the power is odd, 3 is odd, so this will be negative of 3 to the power 3, that is 27. Now again we see that the denominator of minus 27 is negative, we would like to make it positive, so this becomes minus 64 by 27 is the rational number. Okay, what else? Okay, this one I have to copy this. Let me copy this one, duplicate. So this one, this was part number 8. Okay, this is 8. Okay, so we have what is this? First you have to observe the structure of the expression given. So basically it's something raised to the power minus 1. So it's a reciprocal of the subtraction of two rational numbers, and not rational numbers, the subtraction of two exponents. The first exponent is 4 by 3 raised to the power minus 1 and the second exponent is 1 by 4 raised to the power minus 1. The subtraction of these two exponents and the reciprocal of the result. So we have to do it, solve it step by step. So 4 by 3 raised to the power minus 1 means its reciprocal, that is 3 by 4. if we know that a by b, its reciprocal is means a by b raised to the power minus 1. This means the reciprocal of the rational number a by b, which is I'm sorry, excuse me. Sorry. So a by b raised to the power minus 1 means the reciprocal of the rational number a by b, which is b by a. So 4 by 3 raised to the power minus 1 is 3 by 4. And the second one minus, it is the same thing, 1 by 4, it's raised to the power minus 1 means the reciprocal of 1 by 4, which is 4 by 1. Okay, and we have the power minus 1. Now we have to solve the difference of the two rational numbers, and we know that this is 3 by 4 plus minus 4 by 1 minus 1. That is, I have used that is from the concept of subtraction of two rational numbers, that is a by b minus c by d is equal to a by b plus the additive inverse of c by d, that is minus c by d. Okay. Now we have to find the addition of the two rational numbers 3 by 4 and minus 4 by 1. We see that the denominators are different, so we have to convert both the rational numbers to their equivalent rational numbers so that they both have a common denominator of the LCM of 4 and 1, which is 4. So this becomes 3 by 4 plus minus 16 by 4 raised to the power 1. This is so now we have, my pen is not working properly. Anyway, so this is, now we have addition of two rational numbers with the same denominator. We will just add the numerator and divide it by the same denominator. So this becomes 3 minus 16 by 4, and we have the power minus 1. This is minus 13 by 4 to the power minus 1. Now to the power minus 1 means the reciprocal. So this becomes 4 by minus 13. Again we have negative denominator, so we would like to have denominator as positive. So this becomes minus 4 by 13. This is the answer. Okay. What else? Okay, we have this one. Let me copy paste. No. Duplicate, and then we have to move it down. Okay, this was part 5. This is part 5. Okay, part 5. So this is the product of two reciprocals basically. So we know that this is minus 3 by 1. Any number, any integer can be always written in the rational form by giving the denominator as 1. So this is minus 3 by 1 to the power minus 1 multiplied by 1 by 3 to the power minus 1. Now minus 3 by 1 to the power minus 1 means the reciprocal of a rational number. So the first one becomes 1 by minus 3 and the second one becomes 3 by 1. Now we can clearly see that this is nothing but 3 cancels. This is nothing but 1 by minus 1. This is minus 1. Let me check if I did it correctly. Minus 3 by 1 reciprocal is 1 by minus 3. Okay, and 1 by 3 reciprocal is 3 by 1. Okay, yeah, it's fine. So we completed the question number 9. If you wish, you can pause the video and take a screenshot. Okay, let's do question number 6. Is this the last problem? Question number 10? Yeah, question number 10 is the last problem to solve. Question number 10. Okay, so we have a little complex powers going on. Anyway, no problem. So question number 10 part 1 says simplify. Okay, so here we have 3 powers. First, the rational number, the base is minus 1 by 4 raised to the power 2, again raised to the power minus 2, and again raised to the power minus 1. So we will apply directly the formula. So the first one, I am not writing the expression, I am directly writing the formula. This will be minus 1 by 4 raised to the power will be the product of all the powers, that is 2 multiplied by minus 2 multiplied by minus 1. So this is minus 1 by 4 raised to the power 2 into minus 2 into minus 1 is 4. 4. Okay, 4. So this is nothing but minus 1 raised to the power 4 divided by 4 raised to the power 4. So this is minus 1 raised to the power 4. So the base minus 1 is negative and the power 4 is even. So this is 1 to the power 4, that is 1, divided by 4 to the power 4 is 60. How much? 4 to the power 4. 16 into 16, 256. 16 into 16, that is 256. Okay, and okay, let me copy paste the part 4. Duplicate. This is part 4. Okay, part 10 is giving problem. Anyway, so this is a division of two exponents. The first exponents, the powers, the rational number raised to some power is minus 2 by 3 raised to the power 7, and the second one is minus 2 by 3 raised to the power 4. We see that the base of the two exponents is same, that is the base is minus 2 by 3. So we will apply here. Also we also see that the first, we know that a by b raised to the power m divided by the same base a by b raised to the power n equals a by b raised to the power m minus n if m is greater than n. We know this law. So it directly applies to this problem. So we say we see the power 7 is greater than power 4 and the base is same, minus 2 by 3. So this becomes minus 2 by 3 raised to the power 7 minus 4. This is minus 2 by 3 raised to the power 3. This is minus 2 raised to the power 3 divided by 3 raised to the power 3. This is minus 2 raised to the power 3. We see that the base minus 2 is negative and the power is odd. So this will be negative of 2 to the power 3, and this is 3 to the power 3. So this is minus 8 by 27. This is the answer. Okay, what else? Okay, we have the third one. Let me copy paste. Duplicate, and I will need to move it down. This was part 3. Okay, this is part 3. Okay, so this is okay. So this is we also see here it's a division of two exponents where first exponent first power is minus 3 by 2 raised to the power 5 and the second one is minus 3 by 2 raised to the power 6. The bases are same. The base is same, that is minus 3 by 2, but the powers are different and the first power 5 is less than 6. So we will apply this law that a by b raised to the power m divided by a by b raised to the power m equals to 1 by a by b raised to the power n minus m if m is less than n. So directly applying this formula, we say that the result is 1 by minus 3 by 2 raised to the power 6 minus 5. 6 minus 5. This is 1 by minus 3 by 2 raised to the power 1. This is nothing but 1 by this is nothing but 2 by minus 3, and we have to make the denominator positive, so this becomes minus 2 by 3. So this is the answer. Any more question left? No, I think we are done. So I hope this video was beneficial to you. I just discussed, I solved some problems based on some laws. There are some laws left that I will discuss in the subsequent videos. This was part 1 on the laws of exponents. There will be another 2 or 3 parts that will cover all the concept of laws of exponents, and also I will try to cover as much variations of problems possible from the textbook of author RS Aggarwal, and there are some really good conceptual problem that can come from this chapter, exponents. It is a very important chapter. I am stressing it again. That will be this concept will be heavily used in your future classes, especially in class 11 and 12. It will often be used in mathematics. So please make your concept of the concept on the exponents very clear. I am trying my best to explain it as simple as possible with as many variations of problems possible. So that was it for today's video. Thanks for watching, and once again, please support me by subscribing to my channel, and if you like my videos, and if these videos are beneficial to you, then please share them with your friends, and yes, and also once you are subscribed, please do not forget to press the bell icon so that you will be notified by my future videos. Once again, thanks for watching, and until the next video, take care and bye.